are from Group 10. This is our group member.
Hi, Assalamualaikum. My name is Muhammad Shukri bin Jalal.
First, for introduction, bridge is one of the most important structure in use in human daily life at the present time. Can be seen that today, every country has their own bridge. Bridges are generally used to connect between two lands or two places. Generally, there are 6 basic bridges formed. Each bridge's type has their own specialty and functions. For this group, the design of the bridge has been chosen, which is PRATT design. A PRATT truss has vertical member and diagonals that slope down towards the center. Under balance loading, the internal diagonals are tense, while vertical components are compressed. If pure tension components are utilized in the diagonals, crossing elements toward the center may be required to absorb concentrated live load as they traverse the span. For this group bridge design, the dimension and measurement of the bridge are as follows. Next, the problem stated for this project is to know the suitable design and measurement of the bridge based on the load to be charged, to make an estimation of the load that the bridge will receive at one time, to do the analysis of the internal force of the bridge and the deflection that might occur on the bridge. The objective of the project is to choose the most effective and the best design of the bridge to withstand any types of load that being applied, to ensure that the bridge can withstand the load that applied to it, and to know the deflection of the bridge that might be happen, to calculate the internal force of the bridge and to calculate the deflection of the bridge. The scope of the project is to design the bridge based on the suitable design and according to common bridge design, to ensure the bridge can withstand the load so that the bridge will not collapse, to do the analysis of the bridge by using manual calculation and Pro software.
Hi, my name is Josephine Murigia, analyst of the truss. Truss is a structure of connected element forming triangular unit, and a bridge was load bearing superstructure is composed of a truss is a truss bridge. In order to simplify the calculation, truss are generally assumed as pin connection between adjacent truss members. For the design point of view, however, the pin connection assumption is considered for security concern and also for simplifying the structure design and analyze. There are several methods of truss analysis, but the two most common are the method of joint and method of section. In truss analysis, a negative member axial force implies that the member or the joint at both ends of the member are in compression, while a positive member axial force indicates that the member or the joint at both ends of the member are in tension. Internal forces in plane trusses. Trusses are structural systems that consist of straight and slender members connected at their ends. The assumption in the analysis of plane trusses include the following. The first one is members of trusses are connected at their end by frictionless pins. The second is members are straight and are subjected to axial force. The third is members deformation are small and negligible. The fourth is loads in trusses are only applied at their joint. The formulation of stability and determinacy in truss is as follows. The first one is M plus R less than 2J is equal to structure is statically unstable. M plus R is equal to 2J is equal structure is determinate. M plus R more than 2J is equal to structure is indeterminate. The load. There are two types of applied loads in this bridge, which is uniform distributable load UDL and point load. For the self-weight of the beam of this study is based on the EN 1991 Eurocode 1 action on structures. The selected steel beam for this bridge study is UB610 x 305 x 238 British steel in 2017. According to the JKR specification, the thickness of our project bridge pavement are 250 mm as a standard thickness, and the width of the one lane of pavement is 3.5 meter. It is the maximum allowable width value of the pavement. That's all.
Hi, Assalamualaikum. My name is Muhammad Arif Afifi bin Jupri. For the next part is analysis and discussion. There are two types of applied load in this bridge, which is uniform distributed load and point load. The value of density of reinforced concrete of 25 kN per meter square is from the usual density of reinforced concrete. Thickness of the pavement of 250 mm and the width of the one lane pavement of 3.5 meter is get from the JKR specification. The type of structure of UB610 x 305 x 238 also have been chosen according to the standard. The proposed specification are as follows. The total length of the bridge is 50 meter. The length of member between two joints is 5 meter, and lastly, height of the bridge is 9 meter. Next is the flow of the bridge calculation. For the first step, it decide on the bridge design and then identify the bridge degree of determinacy and calculate the bridge stability. And then using the limpo to design the bridge. Then determine the bridge depth and life load and calculate the internal forces and bridge deflection manually using alternative method. And then in limpo, assign support and apply loads to the proposed bridge and use limpo to analyze the bridge internal forces and deflection. After that, compare the internal force and deflection for the two methods and determine the percentage error for the bridge internal forces and deflection, and make sure the percentage error must be less than 10%. For the full load distribution, as you can see on the first picture, is the load distribution that have been made using the limpo, and on the bottom left is the load distribution for real work, which is the UDL has been transferred into point load to calculate the internal force, and on the bottom right is the load distribution for virtual work, which is the 1 kilonewton load that have been applied on the middle of the bridge with its joint F.
Hi, my name is Muhammad Ismail.
For the data analysis, first thing we need to find the degree of determinacy. For the calculation, it can be done by using the formula m plus r equal to 2j. For our bridge, the degree of determinacy is 40, which is statically determinate for internal force of truss member in real work. As you can see, for the first picture, there's a manual calculation using alternative method, and the second picture is the data obtained for internal force in real work from LinPro software. As you can see, the difference is not very noticeable. For example, point A to point B by using alternative method, the value are 1649.96, while from LinPro software, the value are 1676.75, and the difference between this value are 26.79. The next part is internal force of truss member on virtual work. The first picture is a calculation using alternative method. For the second picture is the data obtained for internal force on virtual work from LinPro software. As you can see, there is not much difference between the values from the alternative method and the data obtained from LinPro. An example, from point A to B, by using alternative method, the value are 0.28, and it is the same as the data from LinPro software. So the next part is a displacement at joint F. For the displacement, it can be calculated using this formula, which is sum of FUL divided by AE. According to table, the sum of FUL is 410692.7. The product of the truss cross-section area and the modulus of elasticity will be used to divide the value. The deflection value obtained using LinPro software is 0.06767 meter, while the deflection value obtained using the formula is 0.06845 meter. For percentage error is the process of comparing a manual calculation to an exact value acquired using software. The percentage must not exceed 10% of the error. Percentage error for internal force for this project is 0.23%, while percentage error for deflection is negative 1.15%.
Assalamualaikum, my name Muhammad Azri bin Nizamdin. For summary, the deflection of the truss is calculated with the principle of the virtual work method by putting a 1 kilonewton load at joint F in the structure. The comparison made between manual calculation and LinPro some difference. For example, in the manual method, the value of internal forces is 1649.96 kilonewton, meanwhile using LinPro is 1676.75 kilonewton. For conclusion, we can also compute the force acting on each bridge member and determine the type of force acting on each part. Aside from that, we can recognize and comprehend the tension and compression that occur on a bridge. From this project, we know the data required to ensure that software or module execute its function. Last but not least, much experience and knowledge can be earned from completing this project. Working as a team in this pandemic era taught us how to communicate properly to solve a problem using online medium, since we can't meet face to face. We also divided the task equally to complete the project without any issues.